Welcome to the lesson on 12.1 arithmetic sequences. So the key question we'll be asking today is, what are algebraic ways to define an arithmetic sequence? Well, before we do that, we need to sort of define what a sequence is and then what arithmetic is. Let's investigate arithmetic sequence here. Okay. Well, let us assume that there are 14 steps. With vertical distance between steps is 7 inches. And the total vertical distance is 98 inches. And there are two ways of looking at this. One, we measure from the bottom. We call that b sub s. And we measure from the top. We will call that from t sub s, right? And s will represent the number of steps you take. Well, if you take 0 steps, you've gone 0 meters, 0 inches, right? And if you take 1 step, you add to that 7 inches, and then you take one more step, you add 7 to the previous result, which means you got 2 7 steps, right? So this right here will be the formula. Can you guess what the next one would be? If you said 0 plus 3 times 7 equals 21, you're correct, because with the initial step of 0, height of 0, plus 3 steps that have 7 inches each yields 21. How about the next one? That's right, it's 28. And we'll do the t sub s in class, so don't worry about that one. And if you feel brave, go ahead and try it at home. So the domain of that is, the domain of the b sub s is just values of s, right? Which is 0, 1, 2, 3, 4, 5, and so on and so forth. Oops, I guess I did it backwards. Okay, so the equation for that is 0 plus 7s, right? So looking at that, the steps are 0 through, all the way to, you keep filling it in, dot, 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 all the way to, there are a total of 14 steps, right? You go ahead and fill out the blanks over here, guys, but, and I'm just going to put blank, dot, dot, dot for myself. But if you were to list it out, let's say there's 1,000,000 steps, it's kind of silly to write out everything, right? So the way we actually do it, this more practical way, is write first few steps to establish a pattern, and then dot, 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 continue in the same fashion, and the last number, okay? And the range is the same thing. If you didn't take any steps, it's 0, 7, 14, it goes up by 7, right? And then you got 35, 42. You go ahead and fill it out as a practice. And then the last value is 98. And that's the shorthand right there. 0, 7, 14, then 98. If you had to graph that over here, I should have said graph of b sub s. This is what you should have gotten, right? It makes sense because for each step, you're going up a very steady amount, right? You don't connect a line because you take 1 step or 2 step, you can't have a half a step or a quarter of a step. So you're going to get a bunch of dots over here. Okay, let's move on. So what exactly is a sequence? Sequence is an ordered list of numbers. That's all it is. And each number in that list is called a term of the sequence. So for example, you got 1, 3, 5, 7, 9. These are a list of odd numbers, right? So this is just sequence. Okay. There's an explicit rule for defining the sequence. Define the terms of the sequence. In position n of a function of n. Okay, let me explain what that means. Let's say you have a list of 1, 3, 5, 7, 9. And what you see in pink is that that's the first number, second number, third number, fourth number, and that's the fifth number. Now, if you look carefully, try to look at the relationship between this and the nth number, that is. It's the second number, right? What do you notice? The value here is going up by 2, right? So it has something to do with 2. Okay, let's try to double 3. What do you get? If you double 3, you get 6. If you double 2, you get 4. Notice the pattern? So for number 5, you get double the 2, you subtract 1. For this one, you double the 5, and you subtract 1, and you get the number that you have over here, right? Yeah, so you need to sort of make a table of these values and do that. What if it's the nth term? Yeah, that's right, you double it and subtract 1. So the function becomes, in this case, the explicit rule, looks like f of n is equal to 2n minus 1. That looks like a function, doesn't it? Right, like a linear function. Okay. So what is a recursive rule? Recursive rule is a term is defined by the position n by relating it to the prior terms, either the one before or even further than that. So in this particular case, if you look, this term over here is 2 more than the previous, right? So if you say f of n, the previous term is defined written as f of n minus 1, a number associated with n minus 1, right? One before, you add 2. That's it. So that's the recursive rule. Okay, we'll talk more about it in class. And here are some definitions. An arithmetic sequence is also known as a discrete linear function. It's a sequence where each of the term has a common difference. Notice that it's going up by 2. So that's called common difference. And the starting position right here, that's the initial term. And you could list that as either as a 0 or 1. Sometimes starting with 1 is more convenient, but sometimes starting with 0, counting with 0, 1, 2, 3, 4, is sometimes more convenient. It depends. So we'll go through this awful list. It will make more sense once we've done other exercises. So hold off on this one. Let's look at this. If you look, I'm starting with 0. 1, 2, 3, 4, 5. That's counting, right? So the numbers that are associated with each position is 2, 5, 8, 11, 14, and 17. Because this is arithmetic, it's going up by a common difference, right? Which is it's going up by 3. So we say that our common difference is 3. So the way we define common difference is the value of subtracted by the previous term. Okay, so this is going up. So the initial term that we have is 2, and its position is 0, right? And the way we write that is, as before, we start with initial position plus the number of times that you go away from it times the difference. 2 plus 3n, right? You can sort of play with that value, right? So when you plug in 0 here, what do you get? You get 2, right? So the n here is 0 through 17. Okay. Oops, my bad. This should be 5. Right here. Cross that off, guys. Write that as a 5. Okay. All right, the recursive form is of what? Because it's going by 3, it's a previous term plus 3. So it's f of n minus 1 plus 3. And n here has to be 1 because we start with 1 over here. If you put 1, you get 0, right? We don't have anything defined less than 0, so that n has to be 1 in order for this to be 0. Is that making sense, guys? All right. Okay, so I think this is enough to get started. The rest of the notes we'll do in class. Have a good night.